Imaginary lines on Earth help us understand geography, climate, and timekeeping. Latitudes run horizontally, marking regions like the Equator, Tropic of Cancer, and Arctic Circle. Longitudes run vertically, including the Prime Meridian and International Dateline, which affect time zones. Some lines, like the 38th parallel and Treaty of Tordesillas, have historical significance. These lines influence navigation, climate patterns, and global divisions.
Welcome to our channel. Today we're diving into the fascinating world of imaginary lines on Earth that help us navigate, define regions, and understand geographical and astronomical phenomena. These aren't lines you can trip over. No, these are constructs of the human mind, born out of our relentless quest to make sense of our place in the cosmos and on this pale blue dot we call home. Think about it, without these conceptual tools, global travel, precise mapping, and even understanding the changing seasons would be a far more chaotic endeavor. It's a testament to our species' ingenuity, our ability to overlay an abstract grid onto a complex, dynamic planet. These lines, from the familiar equator to the more enigmatic international dateline, are more than just cartographical conveniences. They are deeply intertwined with the Earth's rotation, its tilt on its axis, and its journey around the sun. They tell a story of celestial mechanics played out on a planetary scale, influencing everything from the length of our days to the intensity of sunlight reaching different parts of our world. So, you see, these aren't just lines, they're the silent organizers of our global experience, the invisible threads that connect astronomy to geography and time to space. Join me, Namish Sharma, as we embark on this journey to explore these fundamental concepts. We'll peel back the layers of abstraction and reveal the profound science and practical utility embedded within each of these imaginary yet incredibly powerful lines. Prepare to see your world, and perhaps even your understanding of time and space, in a whole new light. It's a cosmic perspective brought right down to Earth. Let's begin with the most fundamental of these lines, the equator. Picture Earth, our magnificent sphere, spinning on its axis. The equator is an imaginary circle drawn right around the widest part of this sphere, exactly halfway between the north and south poles. It's designated as 0 degrees latitude, serving as the primary reference for all other lines of latitude, which measure distance north or south. This line is colossal, stretching approximately 40,075 kilometers, making it the longest of all latitude lines. Its existence isn't arbitrary, it's defined by Earth's geometry and its rotational dynamics. It slices our planet neatly into two halves, the northern hemisphere and the southern hemisphere, a division that has profound implications for climate, seasons, and even the direction storms spin thanks to the Coriolis effect. Now consider the sun's relationship with the equator. Because of Earth's axial tilt, that crucial 23.5 degree lean, the equator doesn't always face the sun directly. However, twice a year during the March and September equinoxes, the sun shines directly overhead at noon on the equator. On these days, every place on Earth experiences roughly 12 hours of daylight and 12 hours of darkness. This balance is a direct consequence of the equator's unique position. Regions near the equator generally experience a tropical climate, characterized by warm temperatures and high humidity year-round, with less distinct seasonal variation compared to higher latitudes. It's a zone of incredible biodiversity, a testament to the consistent solar energy it receives. Moving north from the equator, we encounter another significant line. The Tropic of Cancer, located at approximately 23.5 degrees north latitude. Now, why 23.5 degrees? This isn't just a randomly chosen number, it's dictated by Earth's axial tilt. Our planet doesn't spin perfectly upright as it orbits the sun, it leans. And this lean, precisely 23.5 degrees relative to our orbital plane, is the cosmic architect behind our seasons and the very existence of the tropics. The Tropic of Cancer marks the northernmost latitude on Earth, where the sun can appear directly overhead at noon. This celestial event happens once a year, around June 21st, an event we call the summer solstice in the northern hemisphere. On this specific day, the sun's rays are perpendicular to the Earth's surface along this line. For observers standing on the Tropic of Cancer at solar noon on the summer solstice, the sun would be at its zenith, casting minimal or no shadows. This line defines the northern boundary of the tropics, the region of Earth that lies between the Tropic of Cancer and the Tropic of Capricorn. Areas north of this line are considered to be in the northern temperate zone. The energy received from the sun at this latitude during its summer is maximal, leading to the warmest period of the year for the northern hemisphere. It's a direct consequence of this orbital ballet, a precise point where the sun's apparent journey north pauses before heading south again. Symmetrically opposite to its northern counterpart, we find the Tropic of Capricorn, situated at approximately 23.5 degrees south latitude. Just like the Tropic of Cancer, its position is a direct result of Earth's 23.5 degree axial tilt. This line marks the southernmost latitude on our planet, where the sun's rays can be directly overhead at noon. This phenomenon occurs annually around December 21st, which corresponds to the summer solstice in the southern hemisphere, and conversely, the winter solstice in the northern hemisphere. It's a beautiful dance of celestial mechanics where the Earth's tilt dictates which part of our world receives the most direct solar energy. On this day, as the Earth continues its orbital journey, the southern hemisphere is tilted most towards the sun. For anyone located on the Tropic of Capricorn at solar noon, the sun will be at its zenith, directly above. This line, along with the Tropic of Cancer, delineates the tropical zone, also known as the torrid zone. Regions south of the Tropic of Capricorn fall into the southern temperate zone. The naming, Capricorn, like Cancer, harks back to ancient times when these solstices occurred while the sun was in the constellations of Capricornus and Cancer, respectively. Though due to the precession of the equinoxes, these constellations no longer align perfectly. The names have persisted, reminding us of our long history of observing the heavens. Venturing further north, we cross a truly remarkable boundary, the Arctic Circle, located at approximately 66.5 degrees north latitude. Now, how do we arrive at this specific latitude? It's not arbitrary. It's derived by subtracting Earth's axial tilt, 23.5 degrees from 90 degrees, the angle from the equator to the pole. This calculation, 90 minus 23.5 equals 66.5, defines the threshold for some extraordinary solar phenomena. The Arctic Circle marks the southernmost latitude in the northern hemisphere, where, for at least one day each year, the sun remains continuously visible above the horizon for a full 24 hours, an event famously known as the midnight sun. This occurs around the summer solstice in June. Conversely, the Arctic Circle also defines the region where, for at least one day each year, the sun does not rise at all, remaining below the horizon for a full 24 hours. This is known as the polar night, and it occurs around the winter solstice in December. The duration of continuous daylight or darkness increases as one moves further north from the Arctic Circle towards the North Pole itself, where these periods can last for up to 6 months. This dramatic variation in daylight is a direct consequence of Earth's tilt and its orbit around the sun, creating unique ecosystems and influencing the lifestyles of the people and wildlife that inhabit these high-latitude regions. It's a stark reminder of how profoundly our planet's orientation in space shapes our terrestrial experience. Mirroring its northern counterpart, the Antarctic Circle is found at approximately 66.5 degrees south latitude. Just like the Arctic Circle, its position is determined by subtracting Earth's axial tilt of 23.5 degrees from 90 degrees. This line delineates the northernmost boundary of the Antarctic region, where similar yet seasonally opposite solar phenomena occur. Within the Antarctic Circle, there is at least one day each year when the sun does not set, resulting in the midnight sun. This magical period of continuous daylight occurs around the southern hemisphere's summer solstice, typically around December 21st. It's a time when the South Pole is maximally tilted towards the sun. Conversely, during the southern hemisphere's winter solstice, around June 21st, areas within the Antarctic Circle experience at least one 24-hour period where the sun does not rise above the horizon, leading to the polar night. The vast icy continent of Antarctica lies almost entirely within this circle, making these extreme daylight variations a defining characteristic of its environment. The further south one travels from the Antarctic Circle towards the South Pole, The longer these periods of continuous daylight or darkness become, culminating in 6 months of each at the pole itself. This interplay of light and dark governs the life cycles of the unique species that have adapted to survive in one of Earth's most extreme environments. Now, let's shift our focus from lines of latitude, which run east-west, to lines of longitude, which run north-south, connecting the north and south poles. The king of these lines is the Prime Meridian, designated as 0 degrees longitude. Unlike the equator, whose position is naturally determined by Earth's shape and rotation, the Prime Meridian's location is a matter of human convention. For centuries, different nations used their own prime meridians, leading to considerable confusion in navigation and map-making. However, in 1884, at the International Meridian Conference in Washington, D.C., the meridian passing through the Royal Observatory in Greenwich, London, England, was adopted as the official prime meridian for the world. This decision wasn't arbitrary. Britain was a dominant maritime power at the time, and its charts, which used the Greenwich meridian, were widely utilized. The prime meridian serves as the fundamental reference line from which all other longitudes are measured, eastward or westward, up to 180 degrees. It also plays a crucial role in defining time zones around the world, with Coordinated Universal Time, UTC, being based on the time at the prime meridian. This line effectively divides the Earth into the Eastern Hemisphere and the Western Hemisphere, providing a globally accepted standard for pinpointing locations and synchronizing time, a cornerstone of modern navigation, communication, and international cooperation. It's a human agreement that orders our world. On the opposite side of the Earth from the prime meridian, we encounter one of the most intriguing imaginary lines, the international dateline. Roughly following the 180-degree longitude meridian, this line is where each new calendar day officially begins. When you cross the international dateline, you either jump forward a day if traveling westward or go back a day if traveling eastward. Imagine the implications. You could, theoretically, celebrate your birthday twice or skip it altogether depending on your direction of travel across this line. It's a fascinating consequence of our global timekeeping system, a necessary invention to reconcile the Earth's rotation with our human-defined calendar. Unlike other meridians, the international dateline is not a perfectly straight line. It zigs and zags considerably, primarily to avoid bisecting island nations or contiguous landmasses and thus preventing the confusion of having different dates within the same country or administrative region. For instance, it deviates eastward to keep all of Kiribati on the same day and makes other detours around places like Samoa, Tonga, and parts of Alaska's Aleutian Islands. The international dateline is a practical solution to a geographical and temporal puzzle, a testament to our need to impose order on the continuous flow of time as we circumnavigate our planet. It's where time literally makes a leap. Let's talk more about the 180th meridian itself, the line of longitude that lies directly opposite the prime meridian, or 0 degrees longitude, on the globe. If you were to travel exactly halfway around the world eastward or westward from Greenwich, England, you would arrive at the 180th meridian. Mathematically, it completes the 360-degree circle of Earth's longitude. This meridian passes primarily through the open waters of the Pacific Ocean, though it does cross land in a few places, including parts of Russia, Fiji, and Antarctica. Its significance is intrinsically linked to the international dateline, for which it serves as the primary basis. While the international dateline deviates from the 180th meridian for political and practical reasons, the 180th meridian itself remains the theoretical line where the eastern and western hemispheres, defined by longitude, meet at their furthest extent from the prime meridian. It represents the point where east longitude and west longitude converge. Understanding the 180th meridian is crucial for grasping the concept of global timekeeping and the necessity of the international dateline. It's the longitudinal counterpart to the prime meridian, completing the framework we use to define every point on Earth in terms of east-west positioning. Think of it as the seam on the far side of our global coordinate system. We've mentioned the prime meridian, but it's often referred to specifically as the Greenwich meridian, and it's worth revisiting its profound historical and ongoing significance. The choice of Greenwich, a borough of London, was pivotal. The Royal Observatory, established there in 1675 by King Charles II, was dedicated to improving navigation at sea. For centuries, astronomers at Greenwich meticulously charted the stars and developed methods for determining longitude, a notoriously difficult problem for mariners. By the 19th century, British maritime charts using Greenwich as their Prime Meridian were among the most reliable and widely used globally. This practical dominance heavily influenced its selection as the world's standard. The Greenwich Meridian is not just about 0 degrees longitude, it's the anchor for our entire system of global time. Greenwich Mean Time, or GMT, was historically the mean solar time at the Royal Observatory, and it became the basis for Coordinated Universal Time, UTC, the international standard by which we regulate clocks and time worldwide. So when you check the time against a global standard, you are, in essence, referencing this imaginary line running through a specific point in London. It's a powerful example of how a local point of reference, through scientific endeavour and international agreement, can become a universal standard, shaping how billions of people navigate space and synchronize time across the planet. Finally, let's group together the Arctic Circle at 66.5 degrees north and the Antarctic Circle at 66.5 degrees south under the collective term the polar circles. These two lines, symmetrically positioned in their respective hemispheres, define the boundaries of Earth's polar regions. As we've discussed, their precise latitude of 66.5 degrees is a direct consequence of Earth's 23.5-degree axial tilt. Within these circles lie the realms of the midnight sun and the polar night, phenomena that are both alien and awe-inspiring to those of us living in more temperate latitudes. These are not just lines on a map, they are thresholds into environments of extreme solar illumination cycles. The regions poleward of these circles experience at least one 24-hour period of continuous daylight during their summer, and at least one 24-hour period of continuous darkness during their winter. The closer one gets to the poles, the longer these periods of continuous light or darkness extend, culminating in 6 months of each at the North and South poles themselves. This dramatic variation in sunlight profoundly impacts the climate, creating the frigid conditions characteristic of the Arctic and Antarctic. It also dictates the unique adaptations of the flora and fauna that call these icy, remote and beautiful parts of our world home. The polar circles are a stark and fascinating manifestation of our planet's celestial dance. So there you have it, a journey across Earth's invisible architecture, from the sun-drenched equator to the icy polar circles, and from the Prime Meridian that anchors our time to the international dateline where our days begin anew. These imaginary lines, born from observation, mathematics and a collective human need for order, are fundamental to how we understand and interact with our planet. They are silent navigators, guiding our ships, our planes, and even our understanding of climate and the cosmos. They remind us that even abstract concepts can have profound, tangible impacts on our lives and our civilization. The next time you look at a globe or a map, or check the time zone of a distant land, remember the intricate web of these lines and the celestial mechanics they represent. They are a testament to our quest to comprehend our place in the universe, a quest that continues to unfold. The Earth doesn't come with an instruction manual or visible grid lines. We had to create them, driven by curiosity and the necessity to explore and connect. And in doing so, we've woven a framework that helps us all share this one precious planet. Thanks for watching. If you enjoyed learning about these imaginary lines, don't forget to like, share and subscribe for more interesting and knowledgeable insights. Your curiosity fuels our explorations. Until next time, this is Namish Sharma reminding you to keep looking up and around at the wonders of our world. #Vibrant Namish.